So here we'll go over the four-step process, of problem solving. You'll see this a lot in questions. In our textbook, it says use the four-step process. What do we mean by the four-step process? So let's quickly read this problem. So we have a manufacturer of pharmaceutical products analyzes each batch of a product to verify the concentration of active ingredient. So the concentration of active ingredient is what is being measured. So that's our X. It is not a fixed quantity. It's not a fixed measurement. So therefore, we call it X because it's a variable. The chemical analysis is not perfectly precise, and that's what makes it a variable. Each time it's going to be slightly different. In fact, repeated measurements follow a normal distribution. So that's important. It is normally distributed with mean mu and sigma, the standard deviation, 0.0068. So remember that even if it's not given in the problem that it's sigma, we have to be able to understand that, because we're talking generally about the measurements being normally distributed. We are not referring to a sample. So therefore 0.0068 is sigma, which is the population standard deviation. And that's very important. Sigma equals 0.0068. And whatever the units are, write it down. Don't forget to write your units in these problems. 3 analyses of one batch give concentrations of the 3 numbers that we have here. So our sample is small. Our sample size is 3. So what do we mean by the 4-step process? We read the question. It says estimate the true mean concentration. So even if it doesn't say mean, we can make that assumption, because we cannot, what does it even mean to say what is the estimate the true concentrations? We can only give an average at a 95% confidence level. So if it says estimate the mean, how do we estimate the mean? Estimate mu, the population standard deviation. We construct a confidence interval. So let's see what the statement says. First, we make a clear statement. It's very obvious. You read the question and that's exactly what you're saying. We will estimate the true mean concentration mu of the active ingredient in grams per liter. You can even add using a confidence interval. So write down everything. Use the word true mean. Use the term true mean, because that's exactly what we are calculating or estimating. Use the letter mu, because that's the letter that denotes the true mean or the actual mean, and also mention the units. In formulate, here is where you have to explain which method you're going to use and explain your rationale behind using that particular process or procedure. So as I said, the most important thing when you read the question is to see is sigma given or not. In this case, sigma is given. So if sigma is given, we use the Z procedures to estimate the actual mean mu using a confidence interval. So if we know that we have to estimate the mean, obviously we have to use you have to use a confidence interval to estimate the mean, because that's the inference technique that gives us a range of values using which we can estimate the mean. Important thing to say is why. Why? Because why we're using a Z procedure is because sigma is given to us in the problem. And you always end formulate with the entire formula, because once you write down the formula, that's when you start thinking. You start thinking about what exactly you need in order to complete this problem or solve it completely and come up with a confidence interval. Our next step is solve. So we have state, formulate, solve. Solve is the part where we do all the work. We've done this in previous questions in the homework. We write down everything, the sigma, x bar, n, C, the confidence level, Z star from table C. Depends on what your confidence level is. In this case, it's 1.960. We write down the formula, complete the calculations and complete the calculations and write it in a way that we have X bar, which is 0.8404 plus or minus the margin of error. So this is our confidence interval. Now, the last thing, so we have state, formulate, solve. Solve is where we do all the calculations and come up with the interval that we've been asked to construct in order to estimate the mean. So we have the interval here. Basically, it says that the mean mu lies between 0.8327 and 0.8481 grams per liter. So finally, we have the conclude. Okay, so in simple language, we need to write down exactly what our findings are. And we have to write it very precisely, exactly the way I've presented it here. We are 95% confident. Remember, that was our confidence level. Always start with that. We are 95% confident that the mean concentration of active ingredient lies between the number 0.8327 grams per liter and 0.8481 grams per liter. So we've seen this sort of conclusion in many of the questions we've done so far. So this is exactly how we make the conclusion. We are 95% confident that the mean concentration of the active ingredient is between this number and this number.